Welcome, children. So today we are going to start with the chapter number 15, sound. And how is sound produced? That we are going to understand today. Actually, for production of sound, we need a vibrating object. We have learned that sound can be generated from any vibrating object that will be vibrating from one place to another. With an example of a tuning fork, we will now learn about how a sound is produced due to such vibrations. Actually, tuning fork is a Y-shaped metal-made instrument. Here they have an arm and a handle. If you touch any of the arm to any hard object and pull it, you will find that these arms will vibrate from its place and back to its place, just like any pendulum, and that creates a sound. So the scientific name to the arms is the prong and the handle is called as the stem. So we call this as a prong. This is called as a stem. Okay. This is an instrument. Those who were coming to school, they have seen this tuning fork in our school. Okay. And how it works. So a tuning fork is made of two prongs and a stem. You can see the two arms, that we call it as a prong, and keeping the stem steady. If the prong are struck, they start vibrating. To show the state of air, the tuning fork vertical lines are used. Where the vertical lines are equally spaced, it indicates that the average distance between the air molecules is the same everywhere, and the average air pressure is three regions A, B, and C. It could be is also the same uniform frequency. With that the vibrating sound will be created. If the stem is kept steady, stem of this tuning fork is kept steady, and the prongs are struck to any hard object, it means that they are set into periodic motion in forward and backward direction, like this. Okay. We will also see that the result of such a motion is production of a sound. And if during the vibration the prongs of the tuning fork go away from each other, in that case the air outside the prongs is compressed and the pressure there increases. Such a state of high pressure is created in region earlier closer to the tuning fork, and such a state of high pressure is then created, and the region in which air is at a high pressure and high density is called as a compression. You see, when we move near the tuning fork, it will be away, and after that the compression can be felt. So you see, here the waves are little far away, and here they are much closer to each other. So we can call this as a compression. The waves in the air can be felt that way: rarefaction and compression. Where the waves are very close, we can call it compression, and in the next step of vibration, the prongs of the fork come close to each other. In this case, the air molecules near the prong get more space between them. Okay, to move away from each other. As a result, the air pressure in this region decreases. Such region in which the air is at low pressure and low density is called as rarefaction. This part we will call as rarefaction. Compression and rarefaction. You can see the gap between the two waves because of the air density and pressure. Because of different air pressure and density near the tuning fork and away from the tuning fork. However, the air molecules in this region which were in compressed state, you can see the state where the vibrations are more in a same time period. You can see transfer their energy to the air molecule in the next region. So the air in that region goes to a compressed state only. Such a periodic motion of the prongs create compressions and rarefactions in the air, and these are propagated away from the tuning fork or the prongs. You can see level by level the waves will become feeble as they move away from the tuning fork. And these are nothing but the sound waves. These are what? The sound waves. And when these waves reach our ear, they are caught by the ear, and the eardrum, again, it will be vibrating. Eardrum also gets into motion because of these waves of sound in the air that reaches it. And when the drum also vibrates, accordingly, specific signal reach the brain and we get a sense of hearing any kind of sound, and we can understand what is being said, or if it is a loud voice, if it is a low voice, we can understand with the help of our eardrum that will also vibrate because of the waves of these sound that are moving in the air. And if sound waves are generated in the air, which moves away from the source, is it the air itself or the state of compression and rarefaction created in the air? What do you think? If it is the air creating this change, or compression and rarefactions of the sound waves that are making the air to move in that way, that is a point to be thought of. Okay, and here we can see that air pressure and air density plays a major role in transferring of these sound waves in the way they are being traveled towards our ears. Another experiment that we can perform to understand propagation of sound. Propagation means traveling of sound from one place to another. Propagation of sound is different in different medium. In solid, it will be different. In liquid, it will be different. And in gaseous state, it will be different. Okay, it's not going to be one and the same. We have learned in the earlier smaller classes also that sound travels through some or the other medium. If there is no medium, sound will not travel. In, for example, on the moon, if the two astronauts are talking to each other directly, they will not be able to understand anything, even if they are very close to each other. And why this is so? The moon does not have any atmosphere around it, no air, no mixture of gases. And since there is no medium, which is necessary for generation as well as propagation. Propagation is traveling of sound, of the sound waves between the astronauts who are talking among themselves. Direct sound propagation between them is not at all possible. They need some radio technology to be used to talk to each other there. Therefore, the astronauts use some technology like the one used in our cell phone to communicate with each other. The waves used in cell phone do not need any medium for propagation. But otherwise, we need some medium. Whenever I'm also speaking, if you want to listen in the class, there should be air. On the moon, I can't take this type of a class. Okay. So sound generation and propagation needs a medium. It could be like air, like water, or any a solid object. A simple experiment can prove this, and the experiment arranged, the figure shall be shown to you. In this experiment, a vacuum-tight bell jar is placed on a smooth vertical surface. The bell jar is connected to a vacuum pump via a tube, actually. And we can remove air inside the bell jar, jar that is made up of a glass, and there should be no air. A vacuum can be created. And inside that jar, if we put an electric bell and ring the bell, what do you think? Are you going to hear that electric bell ringing, which is connected to the power supply through the lid? And we can ring the bell and see that we are unable to hear because of the vacuum that is being created around it. There is no medium for traveling or propagation of the sound waves. As the quantity of air inside the bell jar decreases, the level of ringing sound will also decrease as we are creating vacuum by suction pump. If we are removing the air inside the jar, and at this point, the level of ringing will stop when there will be no air in the jar. This actually experiment is demonstrating that sound generation and propagation needs some or the other medium. And air inside the bell jar is totally removed, and therefore we are unable to hear the sound. So I hope this much you try to understand for the day, and for the part we shall do in the next class. Okay. So bye all of you.